Battlestar Galactica takes us to a lot of different places. Gas giants, nebulae, familiar-looking planets, and a few locations that are a bit harder to explain. Some of these are based on real astronomical objects, and others are clearly invented for the show. In this video, I want to go through some of the planets and space locations we see in Battlestar Galactica and compare them with what we actually know about space. Where does the show get things surprisingly right, and where does it take some, let's say, creative liberties? Ragnar Anchorage is one of the first truly alien locations shown in Battlestar Galactica. It is a military weapons depot hidden inside the upper layers of a massive gas giant, chosen specifically because the environment is hostile to Cylons. The key feature that makes Ragnar Anchorage possible in the show is intense radiation, which disrupts Cylon systems. In the series, the gas giant's radiation is strong enough to disable or confuse advanced electronics, while humans can still function inside shielded structures. This makes the planet a kind of natural defense system. We have beautiful examples in real astronomy. Gas giants like Jupiter produce some of the most intense radiation environments in the solar system. Jupiter's powerful magnetic field traps high-energy particles, creating massive radiation belts similar to Earth's Van Allen belts, but far stronger. Near Jupiter, radiation levels are so extreme that unprotected electronics can fail quickly. Spacecraft require heavy shielding, and human exposure would be lethal in a short time. NASA missions such as Juno had to be specially designed to survive Jupiter's radiation, using hardened electronics and protective vaults to shield sensitive instruments. So the core idea behind Ragnar Anchorage is actually scientifically kind of correct. A real gas giant suitable for something like Ragnar Anchorage would likely have thick cloud layers made of hydrogen and helium. Extreme pressure increasing rapidly with depth, powerful storms and turbulence, and strong magnetic fields generating radiation belts. Any station placed there would need to orbit or float in the upper atmosphere, where pressure and temperature are survivable. Going too deep would crush any structure, while staying too high would expose it to violent winds and radiation. In reality, building and maintaining a station in such an environment would be extremely difficult. Continuous station keeping, shielding, and maintenance would be required just to keep it intact. While the radiation concept is realistic, Battlestar Galactica simplifies its effects. In reality, the radiation strong enough to disable Cylon systems would also pose serious long-term risks to humans. Shielding sufficient to protect humans would likely also protect advanced electronics, and the environment would be far less stable than shown. Battlestar Galactica gets the big picture right. Gas giants really are some of the most hostile environments in space, and radiation is a genuine obstacle for both machines and humans. Using such a planet as a natural hiding place is a clever and plausible concept. However, the show simplifies how radiation works and underplays how dangerous it would be for human occupants over time. Ragnar Anchorage is not scientifically perfect, but it is firmly grounded in real astronomical principles rather than pure fantasy. The Maelstrom in Battlestar Galactica is presented as a massive, permanent storm system deep within a gas giant's atmosphere. Unlike Ragnar Anchorage, which uses radiation as its defining danger, the Maelstrom is threatening because of its violent atmospheric forces. It is a place of extreme turbulence, pressure, and energy, so dangerous that even approaching it is considered extremely dangerous. Gas giants are home to the largest and longest-lasting storms we know of. The most famous example is Jupiter's Great Red Spot, a storm larger than Earth that has been active for at least 300 years. These storms are powered by immense internal heat, rapid planetary rotation, and thick, multi-layered atmospheres. Unlike storms on Earth, gas giant storms are not surface phenomena. They can extend hundreds of kilometers deep, with wind speeds exceeding 400 to 600 kilometers per hour, and possibly much higher in deeper layers. Because there is no solid surface, storms can persist almost forever, fed by constant energy from below. A Viper entering such a storm would face several lethal problems at once. Sudden changes in wind speed and direction would place enormous stress on the hull. Even a reinforced spacecraft would struggle to stay in one piece. As the Viper descends, atmospheric pressure would rise rapidly. Gas giant pressure increases far faster than on Earth, and at relatively shallow depths, it would be enough to crush most known materials. Gas giants produce powerful lightning far stronger than anything on Earth. These discharges could overload electrical systems, ignite fuel or oxygen supplies, or cause a catastrophic system failure. Any one of these could plausibly cause Starbuck's Viper to explode or break apart, even without direct impact with solid matter. From a real-world perspective, Starbuck's Viper, flying deeper into the maelstrom, would almost certainly be destroyed. The combination of mechanical stress, electrical overload, and increasing pressure would lead to structural failure, engine rupture, or internal explosion. So in this case, the show's depiction is surprisingly realistic. Entering a storm like this would definitely be fatal. Which brings us to Lee-Adama. Lee-Adama enters the maelstrom briefly and manages to escape, and this is where realism becomes more questionable. If Lee stayed in the upper layers of the atmosphere, the pressure would still be survivable for a short time. Winds, while violent, might be navigable, with enough thrust, and a fast retreat could be possible. However, it would require extremely precise piloting, very short exposure, and honestly a great deal of luck. Any deeper descent or prolonged exposure would almost certainly make escape impossible. So while Lee's escape is technically plausible, it sits at the absolute edge of realism. The Tomb of Athena plays a small but important role in Season 2. It contains a star map pointing toward Earth, preserved inside an ancient structure built long before the colonies. Beyond establishing that this knowledge is old, the tomb itself is not especially important from an astronomical point of view. What matters is what the map points to, the Lagoon Nebula. In the series, the Lagoon Nebula is used as a real, identifiable object in space. The Colonials treat it as a fixed reference point, something that can be recognized visually and used to confirm their position. This immediately grounds the journey in real astronomy rather than vague prophecy. The Lagoon Nebula is a genuine astronomical object, also known as Messier 8. It is a large star-forming region located roughly 4,000 to 5,000 light-years from Earth. Through telescopes, it appears as a bright, cloudy region filled with glowing gas, dark dust lanes, and young stars. Nebulae like this are usually large enough to be seen from great distances, distinctive in shape and structure, and stable enough on human timescales. This makes them suitable as long-term navigational markers. Humans navigated on Earth using star constellations, not because the stars were close, but because their patterns remain consistent. Space navigation works on a similar principle. While individual stars move over very long timescales, large structures like nebulae remain recognizable for millions of years. In that sense, using a nebula as a waypoint is far more realistic than using a single star or a vague region of space. Among all the locations in Battlestar Galactica, the Lagoon Nebula is one of the most scientifically grounded. It exists, it is well studied, and its use as a deep space landmark is reasonable. Unlike the Lagoon Nebula, the Ionian Nebula in Battlestar Galactica is not a real astronomical object. It is a fictional region of space created specifically for the series. In the show, the Ionian Nebula is visually dense, turbulent, and unstable. Ships experience sensor failures, distorted readings, and spatial anomalies. It is within this environment that Starbuck reappears long after her Viper was destroyed in the maelstrom. No physical explanation is offered, and the series makes no serious attempt to ground the event in known science. In reality, nebulae are extremely diffuse. Despite their dramatic appearance in images, the density of gas inside a nebula is far lower than even the best vacuums we can produce on Earth. Nebulae do not behave like storms or clouds. They are vast, quiet regions of gas and dust spread over many light-years. Even star-forming nebulae, which contain energetic processes, are not hazardous to spacecraft in the way the Ionian Nebula is portrayed. Starbuck's return inside the Ionian Nebula cannot be explained through known physics. Given what we established earlier about the maelstrom, her Viper should have been destroyed beyond recovery. The show does not suggest advanced technology or natural processes at work. Instead, it treats her reappearance as a miraculous event, outside the rules that apply elsewhere in the series. Up to this point, Battlestar Galactica often been science, but keeps it recognizable. With the Ionian Nebula, it stops trying to explain events in scientific terms. The nebula becomes a narrative device, rather than an astronomical object. The Ionian Nebula is not realistic. Real nebulae do not behave this way, and nothing in modern astrophysics supports the idea that such a region could exist or cause the event shown. However, this appears to be a deliberate choice. The show uses the familiar language of astronomy to frame an event that is meant to be unexplainable. Okay, let's move on. When looking at the planets of Battlestar Galactica side by side, one of the first things that stands out is how similar many of them appear. Most are rocky, Earth-like worlds with breathable atmospheres, familiar landscapes, and gravity close to what humans are used to. This similarity is deliberate, but it can hide important differences in how these planets function as places where humans can actually live. Kobol is clearly a habitable planet in physical terms. It has liquid water, stable terrain, and an atmosphere that humans can survive in without assistance. Nothing about Kobol suggests it is naturally hostile to life. What makes it distinct is that it is abandoned. Its habitability is unquestionable, but its emptiness shows that environmental conditions alone do not determine whether a planet remains a home. From a scientific point of view, this is realistic. A planet can be perfectly habitable and still lifeless or deserted. Caprica represents the most complete example of a livable world. It appears geologically stable, biologically rich, and climatically balanced. In real astronomical terms, Caprica would be considered an excellent Earth-like planet, one capable of supporting a complex, long-term biosphere. Its failure as a home has nothing to do with its environment. Instead, it highlights the fact that even ideal planets can become uninhabitable due to external or technological factors, rather than natural limitations. The algae planet occupies a very different position. It is technically habitable, but only just. Life exists there, but in a highly limited form. The planet can provide food and breathable air, yet it lacks the ecological depth needed to support a stable human civilization. From a real scientific perspective, this kind of world is entirely plausible. A planet might support microbial or simple plant life while still being unsuitable for long-term human settlement. The algae planet shows that habitability exists on a spectrum rather than as a simple yes or no condition. The 13th colony, often referred to as Earth-1, closely resembles Caprica in its natural state. It was once capable of supporting an advanced civilization, and there is no indication that its environment was ever inherently unstable. Its uninhabitability is the result of destruction, not planetary failure. This reflects real concerns in planetary science, where habitability can be lost through environmental collapse, radiation, or atmospheric damage long after a planet has proven itself suitable for life. Our Earth, or Earth-2, stands apart not because it is more advanced, but because it is naturally balanced. It has a stable climate, abundant liquid water, a diverse biosphere, and long-term environmental resilience. Astronomically, this combination is rare, but realistic. What makes Earth-2 distinct in Battlestar Galactica is that it does not require technological intervention to be livable. It is habitable in its simplest form, without infrastructure or artificial support. Taken together, these planets are similar in appearance but very different in outcome. The show simplifies how often Earth-like planets appear, but it does a reasonable job of showing that habitability is not just about having air to breathe. Long-term stability, ecological complexity, and resilience matter just as much as atmosphere and temperature. When you put all these places side by side, you start to notice something. Very few of them are completely made up. Most of the planets and space locations in Battlestar Galactica are built on real ideas from astronomy. Gas giants with radiation, massive storms, nebula that can be mapped, and rocky worlds that sit just on the edge of being livable. When the show bends the science, it usually does it for a reason. Not to show off, but to make space feel like a place that actually pushes back against the people moving through it. Ragnar works because radiation really does make some parts of space dangerous. The maelstrom feels lethal because storms on gas giants really are violent. The Lagoon Nebula works as a reference point because large structures in space can be recognized and charted. And the Ionian Nebula stands out because it's the moment where the show stops trying to explain things at all. The planets themselves often look similar, but what happens on them is very different. Some are habitable, but abandoned. Some can keep people alive, but not for very long. Others are ruined by what lived there before. Battlestar Galactica doesn't always get the science right, but it usually starts from something real. And that's why, even when it stretches the rules, the universe still feels believable. So that's it. What do you think? Let me know your thoughts in the comments below. Don't forget to like and subscribe. Until next time.